Hi again, this is Alan Binder, and in this talk I'm going to talk about the moon, what we know about it, and what Lunar Prospector found out about the moon. The moon, as all of you know, orbits the Earth and goes around roughly in 1 month. It's about a quarter the size of the Earth. It was formed shortly after the Earth was formed. Most scientists believe that it was formed when a giant impact occurred on the Earth, and the splash that was splashed into orbit coalesced to form the moon. The moon was almost certainly totally molten initially, and it began to differentiate as it cooled. A very small core, probably 300 to 400 kilometers in diameter, which is only 1 or 2% the mass of the moon. In contrast, the Earth's iron core is 30% of the mass of the Earth. A little core formed, and then olivine and pyroxene, two iron and magnesium-rich minerals, which form not only the lunar mantle, but also the Earth's mantle, crystallized out to form the mantle of the moon, which consists most of the body of the moon. Towards the end of the differentiation sequence, light plagioclase, a light-colored mineral which is rich in calcium and aluminum, began to crystallize and floated up because it's lighter than the magma from which it was crystallizing to form the crust. And the crust, we believe, is 60-70 kilometers thick, a little bit thicker on the far side and a little bit thinner on the near side. After this epoch of crustal formation, the moon was being still bombarded by impacts of great number from comets and asteroidal fragments and debris from the origin of the solar system. And so the first half a billion years of lunar history was a period of intense bombardment, and the old highlands lunar crust is just battered with innumerable craters. About 4 billion years ago, or maybe a little earlier, the evidence of earlier Mare basalt eruptions is probably erased by all the impacts. You began to form gigantic areas of lava in the huge craters that were formed. Actually, we call them basins when they're big enough. And so the dark areas on the moon are lavas similar to the lavas that you find in Hawaii and other areas of volcanism. This is called Mare basalts, and these rocks are richer in richer in iron, magnesium, and in some cases titanium. So this activity continued, the volcanic activity filling the Mare basins, continued to at least 3 billion years ago, and perhaps some of the flows are even younger. And finally the moon then cooled down, and most of the activity has ceased. Since that period, however, the moon, because it is cooling, has begun to have very large stresses in the outer crust, and the evidence that we have from the seismic data obtained during the Apollo era and from pictures taken of the moon and from work that I have done on the stresses caused by this cooling, you have fairly large moonquakes. And this is the basis, by the way, of the science fiction story that I wrote called Moonquake. And it gives quite a bit of information about the moon and its history and the moonquakes themselves, because as one reads this story, you need to know the background. So this is a brief history of what we knew about the moon. And what did Lunar Prospector add to this? Well, we were the first spacecraft to ever go into low polar orbit. Our altitude was 60 miles or 100 kilometers. This is our primary mapping orbit, and we mapped the moon over and over again because the moon turns under the spacecraft once a month, and so we continually obtain all the data over and over. Now, this is good because these experiments are mostly nuclear experiments and nuclear detectors of various types, and the signal is very small, and so you have to integrate over a long period of time to get good data. Well, the first thing we did was provide the first complete global gravity map of the moon. Now, this is important not only for science, because it tells you about the crustal structure and the internal structure of the moon, but also you have to know what the gravity field is in order to figure out how much fuel you need to stay in orbit. Before we went with Lunar Prospector, the various models varied by a factor of 10. I chose what I thought was the best model and made my calculations for the fuel load based on that, and then multiplied by a factor of 3. And it turns out that model was quite accurate, so the extra fuel I had on board for orbital maintenance I could use for an extended mission. So that was our first great achievement, and from those data we also were able to tie down the size of the core. The next thing was mapping the moon in terms of its elemental composition. This was done with a gamma ray spectrometer. and we provided the first complete global maps of uranium, thorium, potassium, aluminum, calcium, magnesium, silica, and titanium, and a couple of other trace elements. Then, in addition to this, we wanted to search for water. Now, the moon, we know from the Apollo samples, is completely anhydrous. There's simply no water there in the rocks at all. It's drier than the driest thing you can find on the Earth. And of course, water is very important for life support and for the future development of a lunar colony. So there had been a theory that ice brought to the moon by comets and the solar wind and some other meteorites might be frozen in permanently shadowed regions in the poles. And so we had a neutron spectrometer on board which mapped these deposits. Now, that instrument actually maps the hydrogen in the water, or if it's not water, it's hydrogen from the solar wind, which is of use in any case because there's oxygen in the rocks, and if we find the hydrogen, if it isn't water, we can make water from it using the oxygen from the rocks and the hydrogen in these deposits. So we discovered these deposits in the polar regions, which is very significant. Then we mapped the magnetic fields of the moon. Again, this is the first complete maps of the global magnetic fields. Finally, the last experiment was an alpha particle spectrometer, which looked for gas release events which had been noted during the Apollo days. So Lunar Prospector, even though it was very inexpensive, provided an enormous amount of data for lunar science, and in particular about lunar resources. And of course, that's what we are really interested in. That's what we call Lunar Prospector. Lunar Prospector. We wanted to show that we were finding resources which would be of value for humanity. Thank you.